Hello! So today we find ourselves with the law of cosines. Now, so far we've solved right triangles using right triangle trig, and we have talked about how certain relationships, so if I was given, let's say, side, 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 right away I know that there's one triangle. Angle, angle, side, right away I know that there's one triangle. Angle, side, side, whoo, I got a test. I might have one, I might have two, I might have none, given the information, okay? We also know that we can solve using the law of sines if we're given corresponding information. But let's say that we're just given three sides. So little a, little c, and little b. Don't forget that the angles are the capital letters. And then you have the corresponding sides. So the leg across from that angle is the lowercase. Okay. Well, in the past, we know that if I have little a, little b, little c, I cannot solve through law of sines because nothing corresponds. So we have dropped down in altitude to create two right triangles. Okay, we know that there's going to be a height. We'll play with this a little bit. If doing that, then that means that this side might be x, because we know what little b is, okay? And then this would be b minus x. And we could play around with that. Well, if I was to play around with that for triangle 1, the only thing that I would know is that b minus x quantity squared plus h squared would equal my hypotenuse, which in this case is c squared. Okay. Triangle 2 would be a squared. Oops, just kidding. I don't want to start with the hypotenuse. It would be x squared plus h squared is equal to the hypotenuse, which is a squared. Okay, I don't know what h is, don't know what x is, so pardon me. I'm going to try to get my equations to only be a, b, and c, little a, little b, little c. And right now I'm seeing that they both have an h squared. So if I could potentially isolate h squared in one of these, I could substitute it in. We've done this before. Okay, and on the right-hand side, I think the easiest thing for me to do would be to subtract x squared to the other side. So then if I have that, I could take this quantity and substitute it in there. Sweet. All right, let's do that and see where it leads us. So then we get the quantity of b minus x squared plus substituting in the quantity a squared minus x squared equal to c squared. All right, well now there's no h, so that's excellent. We're getting closer to our goal, to only having items that we know the values for. I'm going to distribute the b minus x, so we get b squared minus 2bx plus x squared, and that second quantity only has an exponent of 1, so we don't need to distribute anything out. Ooh, sweet. Okay, my x squareds are going to cancel, so we get a squared plus b squared minus 2bx is equal to c squared. Nice work. Nice work. Okay. X. Well, x is in triangle 2. Okay, we know the hypotenuse is a. X is going to be this little piece, and then we do have an angle C here. So I'm thinking, similar to what we saw when we were deriving the law of sines, that we could say that the cosine, and I'm going to use cosine because I have the adjacent and the hypotenuse. So the cosine of angle C is equal to the adjacent over the hypotenuse. Ha. And then if we multiply both sides by a, we can get x by itself. It would be a times the cosine of angle C. We could then take this value and substitute it in for x. Let's do it. So c squared would equal to a squared plus b squared minus 2b times a times the cosine of angle C. And there we have eliminated any variable other than a, b, and c for us. Nice. Ladies and gentlemen, this is the law of cosines, which I think is so rad that it comes from, I'm going to do it in our school color, that it comes from just playing around with a triangle that we were given, dropping that altitude that we've done so many times to create the height. Whoa, hello. So we say that c squared is equal to a squared plus b squared minus 2AB times the cosine of angle C. And we can actually use this with numerous situations. So if we're given three sides, little a, little b, little c. If we're given little a, little c, little a, little b, and big C. Okay, you've got variations. Also, notice that there are some correlations. Little c, big C, and then little a, little b. Okay, so that's how we can derive or create the other forms of the law of cosines. If this is b squared, that means that little a squared plus c squared, the other two sides, minus 2 times little a, little c, times the cosine of angle b. Or, yep, a squared, little a squared is equal to b squared plus c squared minus 2bc times the cosine of big A. And there are your three variations of the law of cosines. Pretty awesome. I do like the law of cosines. I'm not going to lie. Okay, so let us play around with it a little bit. If we look at example number 1, okay, we're given little a, little b, and big C. So if I were to draw this, now granted, please know it is not to scale, and we say big A, big C, and big B, and we're given little a as 15, big C is 34, and come on, buddy, there we go. Little b is 18. Right away, I see that this is side, angle, side. So we know there's going to be one triangle. I can go ahead and start solving. Okay, so then I'm given little a, little b, big C. So if I'm given angle C, that means it's going to be C squared is equal to a squared plus b squared minus 2ab times the cosine of big C. And I'll always write them out. There is some room for error here just because if you get moving so fast, things can happen. So I'm going to plug in what I know. I know that little a is 15, little b is 18 minus 2 times 15 times 18 times the cosine of 34 degrees. And yes, you will need a calculator. So if we do put this quantity into our calculator, we get 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of 34 degrees. Watch your parentheses, please. In my calculator, I get 101.3197108. On my paper, I'm going to approximate. But from here, I'm going to keep going. So I'm going to take the square root of my answer. I'm not going to approximate until the very end, so we get that it's 10.1 units. Excellent. Now keep in mind, it's just asking us for little c. Okay, go ahead and try this. I'm going to pause your video. Pause it. Try it. I'm going to do my answer, and then I'll come back when it's done. Okay, so hopefully you got 8.0 units approximately. Again, we're given the same type of information, so we know there's one triangle. All right, so yes, you can use the law of cosines to solve for individual pieces, but what matters to us, if I go to the next page, is that we can use it to solve. Okay, that's the super important part. So let's take a look at the first triangle here, for example, number 2. If I were to draw it out and see what we're given, okay, so big A, big B, little c. It doesn't matter where you put those values as long as you have what's corresponding. So big A is 47 degrees, little b is 22, and little c is 27. Yes, we need to see what we're given. In this case, it was side, angle, side, so we know that we have one triangle to solve for. Here we go. It doesn't really matter what you solve for first. Since I was given big A, though, I do want to solve for little a using the law of cosines. I say it doesn't matter because you could drop an altitude and try to go that route as well. Recommend that? Nope, probably not. So if you're given side, angle, side, definitely solve for the side that corresponds to the angle given. Okay, so we'll do a squared is equal to b squared plus c squared minus 2bc times the cosine of big A. All right, so that means we get 22 squared plus 27 squared minus 2 times 22 times 27 times the cosine of 47 degrees. All right, putting that in my calculator, I'm doing it with you guys. 22 squared plus 27 squared minus 2 times 22 times, oopsies, times 27 times the cosine of 47 degrees. Make sure your calculator's in degrees. Okay, I didn't mention that, but it is super, super important. We're not in radian measure yet. So 402.785 approximately. If I take the square root of the full answer, I'm going to get that little a as approximately 20.1. My directions say to round to the nearest tenth, so that's what I'm going to do. Make sure that you are solving for everything. Yeah, so little a is a 20.1. I need to solve for the rest of my angles. At this point, you can use the law of sines if you want to. Since we're practicing and learning the law of cosines, that's what I'm going to stick with. Okay, so let's solve for big B. So that means that I'm going to have, draw a little squiggly, B squared is equal to A squared plus C squared minus 2AC times the cosine of big B. I know little b is 22. I know that little a is what? No, I don't. 20.1. Because we just solved for that. We know little c is 27. Minus 2 times 20.1 times 27 times the cosine of big B. There is room for error here, ladies and gentlemen, so please be careful. This is one big product. You cannot move 2 times 20.1 times 27 without moving the cosine of b, and some of you will do this. Please don't do this. It is not allowed. Okay, so what I am going to do is I'm going to take 20.1 squared and add it to 27 squared. So 22 squared is 484, and that is equal to 1,133.01 minus 2 times 20.1 times 27, so minus 1,085.4 times the cosine of angle B. I'm going to subtract the 1,133.01 to the other side. Okay, so I'm trying to isolate the angle B because that's what I'm solving for. And I get negative 649.01 is equal to negative 1,085.4 times the cosine of angle B. I'm then going to divide both sides by negative 1,085.4. And I get that the cosine of B is approximately 0.598. Now, in my calculator, I am not approximating. Okay, we're going to take the inverse cosine because I need to find what the angle is. How do I do that? With inverses. So in my calculator, mine is, I just have to hit it twice, but for our graphing calculators, it is the second function. Okay, and then I'm going to put second answer, which I think is the entry button on your TIs. Okay, and then I'm going to hit enter. And I get that the measure of angle B is approximately 53.3 degrees. Okay, so now we could write that in our triangle. So this is 53.3 degrees. And to solve for angle C, I'm going to take 180 degrees, because we know that three angles in a triangle add up to 180. So I'm going to say that the measure of angle C, do I have room over here? I do. Let's do it over there. Okay, so that the measure of angle C is going to be approximately 180 minus 47 degrees plus 53.3 degrees. And we get, and I say approximately because we're using 53.3, which is an approximate angle. We had to approximate that. So we get approximately 79.7 degrees. Okay, so I've asked you to write all your answers in one area for me to find. So A is approximately 20.1 units. The measure of angle B is approximately 53.3 degrees. And the measure of angle C is approximately 79.7 degrees. And we have solved using the law of cosines. Way to go, guys. Okay, so I'm going to set up the other two triangles. And then I'm going to solve them on here. But I would hope that you would pause it to give yourself a chance to solve. Okay. Here we go. For these guys, I need the black marker. So big A, little b, little c. Okay, so triangle. I'm going to put big A, big B, big C. Looking at what we're given that this is 38 degrees, little b is 6, little c is 10. So we have side, angle, side. We have one triangle here. Okay, and then for the try this B, again, I'm going to do big A, big B, big C. Doesn't matter where you draw them as long as the information given to you is corresponding. So little a is 15. Little b is 16 and big C is 23 degrees. So side, angle, side. Yes, we have one triangle again. That worked out nicely. Okay. So because I am a little bit of a sucker, I'll do one with you. All right. So, pardon me. So looking at triangle, try these little a. Okay. So I'm going to use the law of cosines and I'm going to solve for little a first. All right, so a squared is equal to, 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of big A, which in this case is 38 degrees. Okay, so I get 36 plus 100 minus 2 times 6 times 10 times the cosine of 38 degrees, and we get that little a squared is approximately 41.44. But again, I'm going to keep that full value in my calculator so I can take the square root of the full answer. I'm only going to round at the end, so it's 6.4 units. Nice. Okay, so we could use the law of sines at this point because we do have corresponding information, or we could again use the law of cosines. I am going to use the law of cosines, and I'm going to solve for big B. So that means we have little b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. Okay, I'm doing this because I know that I'm trying to learn how to use the law of cosines, and I don't really know that well yet. So 6.4 squared is little a, little c is 10, minus 2, 6.4 times 10 times the cosine of angle B. And I remember Miss Patterson saying that this is one big unit, so I can't move the numbers through subtraction or addition. Don't do that. Okay, so 36 is equal to 6.4 squared plus 100. We end up with 140.96 minus 2 times 16.4 times, 6.4. Be careful, don't make that mistake in your calculator. It will most definitely change your value. Minus 128 times the cosine of angle B, which is what we're solving for. So I am going to subtract 140.96 to both sides. Okay, so 36 minus 140.96 gives us negative 104.96 equal to a negative 128 times the cosine of angle B. I'm going to divide both sides by negative 128. Okay, notice I weighted and then I divided. So we get the cosine of angle B is equal to 0.82. We're going to end up taking the inverse of this because we're looking for the angle. And that's going to give us our value. So for whether you have to touch your cosine button twice, or if you have to do the second function, you should get that the measure of angle B is approximately 34.9 degrees. Okay, yay! So little a is approximately 6.4 units. The measure of angle B is approximately 34.9 degrees. And if I take 180 and I subtract the sum of the two angles that I have so far, I'm going to get that the measure of angle C is approximately 107.1. Obviously, my triangle is not drawn to scale. Don't be judgy. All right, so I'm going to pause my video and I'm going to work out the try this B, I hope that you would also pause your video and work out the try this B. Okay, hi. So how'd you do? I solved for little c first because that was the corresponding side to the given angle. I got 6.3 units. Please, 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 you guys, I can't stress this enough. Make sure that you do not approximate till the very end. Your calculators have an answer button, so you can always say, oh, okay, so I'm going to hit the square root button, and then I'm going to hit second entry, and that'll, if you have a scientific calculator, that'll give you your answer in its entirety. Okay. And then I use the law of cosines because, hey, we're in that section, to solve for big A, and plugged in my given information plus what I found little c to be. I subtracted 295.69 over and then divided by negative 201.6 because that is being multiplied to the angle, to the cosine of the angle, pardon me. And then I used my inverse trig function to solve for the given angle. And then I took 180 and subtracted the product of the two angles I knew, which was 23 and 69.5, and got 87.5. So hopefully that was helpful. Hopefully it is straightforward, and now you know. Rad. All right. Have a good one.